The train travels 600 miles in the same time as the truck travels 520 miles. Find the speed of each vehicle if the train's average speed is 8 miles per hour faster than the truck. So here again we find the variables, x to be the speed of the train, y would be the speed of the truck. Again, this time, once again, the table would help us to organize our data here. Distance is equal to rate times time. The distance is given to us. For the train is 600, for the truck is 520. The rate, we assume, is x and y. So the time would be distance over rate. So remember the formula? Here we have distance is equal to rate times time. So the time, if I divide both sides of the equation by r, would be distance over rate. That's what we have here. We have distance over rate, that's the time for the train in terms of x. This would be the time for the truck in terms of y. These two would be equal each other. So in this case, we would have 600 over x is equal to 520 over y. If I cross multiply, this is a proportion. 600y is equal to 520x. This would be my first equation here. I can write this in the standard form by subtracting 520x from both sides of the equation. So I get minus 520x plus 600y is equal to 0. So this is my first equation. My second equation is the fact that the train average speed is 8 miles per hour faster than the train. So x must be equal to y plus 8. So that's my second equation. We have two equations and two unknown. You can use substitution method here because x is solved in terms of y already. If I substitute for each x in the first equation, y plus 8, I can solve for y and then substitute that back and solve for x. So the train travels at 60 miles per hour, don't forget the unit, and the truck at 52 miles. So we can check the answer. It would take the train 10 hours to travel 600 miles at 60 miles per hour, which is the same amount of the time it would take the truck to travel 520 miles at 52 miles per hour. So another example, solving a motion problem. While canoeing on Tikva River, Shannon travels 30 miles upstream against the current in 5 hours. It took her only 3 hours paddling down the stream with the current back to the spot where she started. Find Shannon's canoeing rate in still water and the rate of the current. We're going to let x be equal to the rate of the canoe in still water, and y would be the rate of the current. Table would help us again here. Upstream, when you go upstream, the rate of the current works against us. So it would be x minus y, that would be the rate. When we're going downstream, the rate of the current would help us to move ahead. So it would be x plus y. So that would be our rate in terms of x and y. The time is given for upstream and downstream would be 5 and 3. So rate times time is equal to distance. So the distance covered going upstream would be 5 times x minus y. The distance covered going downstream would be the time, which is 3 times x plus y. So these are the information we have from the table. So here we have our equations. 5 times x minus y must be equal to 30. 3 times x plus y must be equal to 30. We have two equations and two unknown. We can go ahead and distribute the numbers. We get 15x minus 15y is equal to 90. 15x plus 15y is equal to 150. And in this case, the coefficient of y is already opposite of each other. So that's all I have to do, just add these two equations. We get 30x equal to 240, solve for x. Substitute that back into either of the equations, solve for y. So Shannon's rate in still water was 8 miles per hour, and the current was 2 miles per hour. Again, don't forget to include the units at the end.